Hello everyone. So today we're going to talk about a cylindrical coordinate system. This is tutorial number 2, and we're still focusing on the same idea as the last tutorial, where what our goal is try to identify a point in space using a different coordinate system. In the last coordinate system we had Cartesian coordinates, which basically meant we move in the x direction, we move in the y direction, and we move in the z direction to get to a point. However, this time we have different coordinates, which are called rho, theta, phi, and then last one we'll call z. Now, rho, phi, and z are interchangeable with other characters depending on the book you read. Some books will have the rho as an r, some books will have the phi as a theta, and then the z usually remains a z. Now, what does this mean, right? So let's say I draw out a coordinate system like last time. So I had an x direction, a y direction, and a z direction, right? So this is my x, this is my y, this is my z. So where does this r, theta, z fall in? We know where the z goes, right? So one thing is still the same. The z from the last coordinate system is exactly the same. When we want to identify a point that's above or below, we will move in the z direction. But what is the r and the theta, or the rho and the phi? For this demonstration, I'll use rho and phi. So remember that to identify any point in space, we have to move in a specific direction, right? So in this case, let's say that I have a point up here. To identify this in the case where we move in the x, y, z, we can say that we move in the x direction by this much, we move in the y direction by this much, and then we move in the z direction by this much, right? So in the Cartesian coordinate system, we would say that that right there is the x distance we move, this right here is the y distance that we move, and this right here is the z distance that we move, which we can just make them random numbers. We'll say x is equal to 2, y is equal to 3, and z is equal to 2. So we know how to get to that point, and I'll call that P. Now, how do we get there in a cylindrical coordinate system, right? The z is exactly the same because that doesn't change. But now we have a rho and a phi, right? A rho just means what is the distance to that point if you don't worry about the height, right? The direct distance to that point, if you don't worry about the height, is from the origin to right where that height starts, right? So from the origin here, that is rho, and that's a distance. And what is phi, right? Phi is the angle at which you are facing. So if we remember a circle, right? Let's say we're looking at this from the top axis. So my pencil right here is the z-axis going up in the air. Let's say my point is over here, right? And this is the starting point of my angle. I would have to go that many degrees, which I can say that, let's say that is 60 degrees. I would have to go 60 degrees from this point to be able to face the point which I'm interested in. It's the same thing in this case. So if this is my x-axis, positive x-axis, from here to be able to face directly towards the point P, I have to move a certain angle, and that angle is called phi. Now this looks a little bit clunky, so what I'll do is I will draw this without the x, y, z, and instead just draw this with the rho, phi, and z. So again, we have our x, y, z, but I'm not going to label them. And let's say our point up here is P, which is the one we're trying to identify. So first thing we can do, again, is we know that this is, we start from the x-axis, and we know that we have to rotate a certain amount to be able to face this point. Now, don't mistake this as rotating all the way around to here and face it like this, because this is a 3D view, right? If you look up here, this makes sense because I've drawn these lines underneath, but right here, it may look a little weird. So I'm just going to draw these lines to help you understand where this point is in space. So you can see that this point is up here in space. Now, when I start from the x-axis, I have to rotate about that much, right? So if I draw a line to where this point reaches the plane here, I have rotated that much to be able to face this point P. And once I've rotated, the next step is to find out how far out do I move to get right underneath that point. In this case, I go from the origin to here, which I'll call that as a distance rho. And then the last thing is how far up or down do I have to go. So in this case, I'm going up here a distance of z. And this, remember last time we had a x, y, z, and up here, if we use the example, we have 2, 3, and 2, which is x, y, and z. So it's written like this, which we'll call point P. Now, in terms of rho theta z, the way you write it, again, is just you write the rho first. You write, sorry, not the theta, the phi. You write the phi second, and you write the z last. So let's say that this distance was some random number 5, right? So what we have here is rho is 5. Let's say that this angle is about 60 degrees, so we can write 60 degrees, and then this z here is, let's say it moves up 10, so we will say that's 10. Now usually the coordinate system for cylindrical coordinates is not written like this, because this looks a little bit clunky, but you can write it like this if this helps you understand.